we can all agree this is how we can write this thing. So anyway, we are also told that the utility function, actually I'm the one who told you. The utility function is going to be ln of x. So the first derivative is going to be 1 over x, right? So it's going to be 1 over x. So under each state, so my advice is for you is that you should do this thing. So step number 1, find the state payoff. Find the state payoffs. So under, again, we can see that there is 2 states. State 1. So the payoff for state 1 is going to be equals to what? It's going to be equals to the sum of and this is going to be equals to the so for asset 1, which is risky asset S, times the payoff for state 1, which again is going to be 200 rand, right? And then the amount of security to you should buy, the payoff is going to be 1,1, right? So this is for state 1. For state 2, you are actually going to have 0 for state 1 plus 1,1 again for stage 2, right? I hope we all agree. If you can stop me. I don't want to do understand. So anyway, so this I advise you to go for step 1. For step 2, you will have to again, so remember that you have to solve 2 n plus 1 equation, right? So depending on how many assets you have. So in this case, you have 2 assets. So you will have to solve this equation for each asset, 1 for risky asset, 1 for risk-free asset, and then you have to solve this one, right? My advice is that you try to solve this one first, since you only have 2 assets. If the market is complete, try to solve this equation first and then simplify it. So how do I simplify that? We are told that there's some the amount times the price we buy should actually be equals to our wealth, right? And asset 1, the amount for 1 you buy, asset 1 cost 100, and the amount for 2, let's say it costs 1, right? And then we see that the wall was going to be equal to, and then you would try to simplify these things. You can see that let mu1 be equal to mu, like okay, so I always call this mu. I'm wrong. So it's going to be equal to theta. So when you substitute it back up there, you can substitute it back up there. So this simply means that theta 2 is going to be equals to 1 minus 100 theta, right? If you let theta 1, the amount of asset 1 you are going to buy to be equals to theta, then theta 2, the amount of asset 2 you are going to buy is to be 1 minus 100 theta. And then you substitute these things back up there. So this thing will help you simplify those equations down there. So they implement that for state one. State payoff is going to be 100 theta plus 1,1, 1 minus 100. And then when you solve this 100, so it's gonna be 110. So you are going to have 90 theta plus 1,1. It makes sense, right? You can see now it's simplified. So for state two, again, we say that you are actually one. So basically, this is going to be 1,1 minus 110 theta. Any questions?
Sorry, I have a question. The lecturer did a similar question to that, but instead you see your
Yes.
branches. Can we please see them? Your branches,
My
where
what?
your branches which show your states. Like
Okay.
at the top.
Yeah, I think it's slow. It should reflect. I have one day already.
Yes, yes, I see it now. So you said that you're gonna say 100. I get 100 times theta 1. Okay, no, sorry, but let me just confirm what I'm saying. Yeah, you said 100 equals to 200 theta 1, or am I just confused now? Yeah, 200
Are you
state 1. Sorry.
okay?
Yeah, 200 state 1
Yes.
plus 1.1 state 2, right?
Yeah. Yes.
But instead he said he would have said 100 equals to 200 times state 1, and then plus
Can you hear
0
plus 2?
times state 2. Yeah, 100 equals to 200 state 1.
Theta 1.
Yeah, theta 1. And then
Yeah.
he said plus 0 theta 2.
Yeah. 0 theta 2. Okay.
Yeah. So my question is, does it not matter the way we write it, or what? Because he took the ones from the risky asset in this case, right? He took the ones from the risky asset and made one equation. I'm not sure if you see that.
I think yeah, again, I think I understand your question. But then I think you should send me the question, because I think the 100 is for the wealth of a person. Again, so please send me the question so that I can look at it.
Okay, I'll send it on the group.
Okay, no problem. So that we can do the question together. By the way, I can see that my screen is very slow. So you guys can hear me properly, right? Then you can see the work I'm doing. Okay, thank you. So this is where we are right now. So I have simplified the payoffs to this. So this is our state payoffs. So now we only have to solve for one equation. We only had to solve for this equation over here. So how do you write it down? That thing we say that the expected utilities is going to be this is going to be the expectation. It's going to be the expectation of mu x star times di equals to lambda p, right? So you are going to do this for each security, right? There are, again, there is someone is level, but she's not here. Actually, she is the one who asked this question. So there's someone who has their hands up. Is Camilla?
Oh no, that was before, sorry.
Oh, okay. So so now you are going to solve this question for each security, right? You have security one, and security one is the risky asset one, right? So the risky asset one, so we already know, okay, before I go here, I have to write down this thing. So this equation is like this. You will have 1 over x, right? Because we say that the first derivative of our of our ln x is going to be 1 over x, right? So you will have 1x times p of, right? So p of I. So it's basically the expectation of this lambda p. So you have two states, right? So it simply means that to simplify this equation, you will have 1 over x for state one, the p of for asset I for state one, and the probability, right? Because you are looking at expectation. I remember that the expectation of x is going to be x times the probability for state one, all the way to x and the probability for x for n, right? So the same thing applies here. It's just that now we are, again, so now we are dealing with the states. You will have to multiply by the probability, right? So to write this thing easier, I will put the d's up here. So the d for asset one, for state one, times the probability for state one, right? So plus the d, so d for asset one for stage two over x, the payoff for state two times the probability for state one, right? It's going to be equals to lambda pi. I hope this makes sense. I hope this expression makes sense. So I am going to solve it for each security. So for security one, which is going to be risky asset S, right? For risky asset S, we say that you are going to have a, so the payoff for state one is going to be 200 rand. It's going to be 200. It's going to be 200, right? And X, we already know the X is going to be 90 theta 1,1. 90 theta 90 theta plus 1,1, and the probability is going to be 0.5 because they say that the probability of state one is going to be 1 over 2. 1 over 2 is 0.5 plus the payoff for state 2 is going to be 0 over the payoff 1,1 minus 100 110 theta 110 theta, right? Times the probability is going to be 0.5, right? Equals to lambda, and the price for this security we say that is going to be 100, right? So, and then we do the same thing for asset 2. The payoff is going to be 1,1 90 lambda plus 1,1, and then the probability is going to be 0.5. Again, the payoff is going to be 1,1 for stage 2, 1,1 minus 110 theta. The probability is 0.5 equals to lambda actually the price was going to be 1,1. 1,1. I mean 1, sorry, not 1,1. The price was going to be 1. So there is no need to write the 1. Are we still clear now? Is there anyone who still struggle to see how I got to this answer?
I'm lost as to where the 90 came from.
The 90, it came from simplifying when we found the x, right? So so we know that we say that this thing is gonna be 200 theta 1 and then 1,1 times theta 2, right? And then we say that theta 1 is just gonna be theta, and then we're just gonna write 200 theta, and then theta 2 was gonna be 1,1 times 1 minus 100 theta, right? And then when you simplify this, you will have 200 theta minus 110 theta plus 1,1. And then so 200 minus 110 is going to be 90 theta plus 1,1. I just simplified the state payoffs.
Okay, I understand. Thank you.
No problem. Any questions so far? You can raise your hand if you don't understand. I will try to explain it again. And by the way, did you send the question? Okay, you haven't sent the question. So I am going to continue. So how do you solve these two things? My advice is that you multiply this one by 100. You just multiply this by 100. And then you have 1, then you have 2. And then you say 1 minus 2. You can just say 2 minus 1. You can just say 1 minus 2. So if that's the case, you will have 110. Actually, you will have 200. You will have 200 minus 110 all over 90 theta plus 1,1 with probability of 0,5. And then 0 minus 110 again. It's going to be minus 110 over 1,1 plus 110 theta. Probability is 0,5. All this is going to be equals to 0. And then you solve for theta. You can see that there's only 1 theta. So you have the theta there, and then you have the theta there. And then you just solve for the theta. So I assume that at this point, you can solve this thing algebraically to find your thetas. That theta, whatever value of theta you find, is the amount of shares you should buy for asset 1, right? Is the amount of shares you should buy for asset 1. And then you will try to also find for theta 2. Once you have found theta, you will know that theta 2 is going to be 1. We say that theta 2 is going to be 1 minus 100 theta 1. And then you're going to solve for theta 2. Okay, and we know that theta 1 is just going to be theta, right? So the value of theta is just going to be the value of 1 of just as theta. Okay, I will take a look at this question and then, so does this make sense, by the way? I just want to make sure that not again that we are all in the same page. Any question? Do you have any concern? even if you feel like, okay, this idea is not yet clear to me, like not yet cemented, remember that your exam is in less than a day, actually in a daytime. So no question. Okay, no question. So another question which I see it a lot in most of the past exams is this question over here. So I will give you guys 2 minutes to try this question. 2 minutes, and then we can do it together, or at least understand what they're asking. In the meantime, I will be checking if you guys have questions. I can see there's no questions, and I will be looking at the question from Camille. Camila, these questions are not this. Okay, they are not the same. This one is for linear pricing. It's not on the portfolio choice. Unless if there's more question coming. Oh, okay. There they are. Yeah, these questions are for again, they are for linear pricing. It's not for portfolio choice.
I understand. My question is, when we are when we are trying to get our simultaneous equations,
Yeah.
How do we go about it? Do we use your method or the way he used? Because when he did it, he used the price of one state with not of one asset with the multiples of the states of that asset. Do you understand?
Yeah. Okay, so my answer is that these questions are not the same. So there are 2 sections under utility. One is for linear pricing, and then one is for portfolio choice. So actually, they are actually quite the same. If you don't mind, I can try to deviate from here. I hope everyone won't mind. So far, we have learned that you have lambda pi is going to be equals to the expectation of utility of x star d. Okay. So in this question, they no longer tried to use portfolio choice, but then they actually went and tried to find okay, again, who else this again? This method is going to be called it's called linear pricing, right? So where they say that again prices. So again, so at the end, prices is going to be equals to the sum of. So this one is for discrete. So for state up to state n or s, they normally put big S over there. They say that you have p of times lambda s. So again, okay. Again, so these things, they are not necessarily the same, but they are related. So remember that in the question over here, it clearly saying that we should find let's see. Suppose solve for the portfolio for this, solve for the log optimal portfolio. Oh, okay. Okay, I think okay. Again, this one is not that much. Oh, okay. There's no more questions. Okay, I'm gonna go somewhere. I thought this thing somewhere. I think it's here. Okay, yes, I do. Again, I do understand your question, actually. I don't remember where I thought. I think it's here. Yeah. Yes, it's here. So consider two securities. Okay, Kenny, I'm not sure if you still remember the last question where we had to make our portfolio choices, right? So they both have the thing. So they both have the timeline, but then again, you should actually look at at how they ask the question. If they want to know the amount of shares you should buy, you should use that method, or the amount of shares you should buy. If you should use the method where you have the expectation of the utility function, and then again DI and stuff. So they determine how much you should invest in security one. You should look at the question, how they ask the question. And then another question. So this is the method you are referring to, right? So in here, you should look at how they ask the question. They can ask you to calculate the state pricing, or they can ask you to find the artificial probability or stuff like that, or they can say that calculate the risk-free rate, gain rate, or I think your question is similar to this one, where they want you to calculate the risk, the fair price of an asset. So it all depends on how they ask the question. So if so many things. So if the question is about finding the amount of asset, the amount of security, or the amount of security or shares, the amount of shares or stock, then you're gonna use the one where you have to use the expectation of X times DI equals to lambda PI, and as well as the sum of wealth and P, actually. You will have to use this equation, right? And then if they ask you to find the share price or the thing, again, actually, I don't see where your question is. Your question, again, let me read through your thing. Graphically represent the table. I don't see where the question is. The probability of state is going to be one, stuff. Okay, and do you mind also sending me the...
I hadn't written the question down. It was to calculate a fair price.
Yeah,
for the...
now. Yeah, so when it comes to that kind of question, then yes, you will have to use this method. You can see I also use the so I used the same method when I was finding the fair price. As I can zoom in, you can see that says calculate the risk neutral probability and the fair price of security C. So I used the method.
Now I understand now that they are both valid and when to use which one. I was just very confused.
Okay,
yeah. Okay, thank you.
Okay. Did everyone have the same thing? I'm like, on that glimpse should be here. So anyway, I hope that that question was actually helpful for most of you. So it will depend on how they ask the question. Most of the time, the information will be the same, right? But the answer will depend on how they actually ask the question. So anyway, I think I'm gonna, so this one is the proof they would normally ask for portfolio choice, right? So they say that consider an investment with a strictly increasing utility. So non-saturation, you already know these things. And W, this is our initial wealth. There are N securities with payoff D up to N. And the optimal portfolio will satisfy this equation, right? So PI is the price of security I. Lambda is just a constant. Theta is the, can represent the amount of shares of security I. So given that the wealth is going to be equals to 1, I think I will write this one. The wealth of this person is going to be equals to 1. So hence prove that the fair, hence prove that the price of any security with pay of D will be written that way, right? So there should be something important here. I think I have cut it. Hopefully not. I think I cut something. Oh, okay, so it's fine. I will write it down anyway. So we know that the X, your X is gonna be equals to the sum of the thing. I mean, like the prices, okay, the amount of shares you bought times the payoffs, right? So you can say that this thing is going to be equals to R, right? R squared, again, R star, right? So I will just say that, right? So if this is the case, we know from our equation over here, from this equation over here, that you can write this thing. You can say that lambda I is going to be equals to the expectation of first derivative of star di, right? You multiply both side. So I can just lambda outside, and then you have this, and then you multiply again by theta I, like by the sum of the thetas. So you will have this. Yeah, is X star times di. Expectation, actually, I forgot to put the expectation. So by the nature of the expectation, you can basically just take it outside. You will have the expectation of the first derivative of X star, right? Of X star is going to be equals to is going to be equals to the sum of lambda I di, right? Di. So they said something about this thing. It has to be log. And that's why I say that I forgot to underline it. So anyway, if they didn't mention it in this question, I think they didn't mention it. You will assume that the utility of this person is going to be ln of x, right? If this is the case, the first derivative of the utility is going to be what? Is going to be it's going to be 1 over x, right? So these two things are are very important. I have just let them here. So again, okay, sometimes they will have this thing. They will give you both this information, but sometimes they won't. So if they don't, you will have to just write them down. If this is the case, you know that this, you can take this thing down here. You will say it's going to be equals to the expectation of 1 over x, right? And the sum of this thing, the sum of the prices, again, so prices times the P of is going to be x. So we have defined this thing as saying that x star is going to be the sum of the P of times the amount of shares we bought, right? So this is by definition. So basically this thing is going to be the expectation of 1, right? So we say that lambda, again, the other definition is that WALF is going to be equals to the sum of the prices times the amount of the security. So you can just put this thing as W. Né? So they told you that W is going to be equals to 1. The WALF is going to be equals to 1, right? So you'll have lambda times 1. The expectation of 1 is just going to be 1 because he's a constant. Fine. You know that lambda is going to be equals to 1. So you go back to the question. You go back to here, this thing over here, this thing. You will simplify it, and then you're going to put 1 where there is lambda. You will have pi is going to be equals to the expectation of the first derivative of x times di. Né? We already say that the is going to be 1 over our x is going to be actually equals to r star, right? So we can just put r star over there. It's going to be the expectation of 1 over r star di. So this is how they found this proof. So it's one of the proofs they love to ask. So I hope we are good. So this thing is, again, it's going to cut again. So we can take a 10 minutes break, actually 20 minutes break. We can come back at 4, actually at 5, if that's fine. It's going to cut anyway. If you have any question, please don't type it down because it's going to cancel you before you finish typing.